Hi, let's take a few use cases and try to identify which metrics are relevant and which metrics are the right metrics to evaluate the performance of model for each of these use cases. So I have a use case one which is to identify fraud, that is a fraud detection. For this I would like to build a classification model, and because it is clearly either a fraud or not a fraud, so it's a class prediction. And I have another use case where I need to predict if a patient is having a cancer, yes or no, right? And I have another use case where I have to predict whether a particular bank can actually reduce the credit for a customer. Is it in the benefit of the bank or not? So if it's basically a binary class model, yes or no, whether the bank can reduce the credit given, credit possible for the customer based on certain criteria. Okay, so before that, let's see. All right, so we have three or four possible metrics. So the one is accuracy, other one is precision, other one is recall. So let us take each of these use cases and try to understand for each use case which is a good metric to use to evaluate the performance of that particular classification model. Right, before that, a quick recap is that this is how the confusion matrix will look, and we will have actual values in the columns and predicted values of the model in the rows, and from this we get true positive, false positive, false positive, and true negatives. And accuracy is this, which is nothing but total right predictions divided by total predictions. So this would always be, the denominator would always be equal to sum of all these four, which is nothing but the total number of records. And over here, the numerator will be obviously true positive plus true negative. That is the total number of correct predictions. And precision, just a second, precision is nothing but of all the predictions by the model, of all the predictions, either positive predictions or negative predictions. So here, the new denominator has the total number of positive predictions by the model, right? Of these, how many did the model correctly identify? The correctly identified is this, and wrongly predicted as positive are these one. So total positive is this, predicted by the model, and that would be true positive plus false positive. And out of these, the correct ones are this one, true positive. Similarly, I can also check the precision for negative class also, that is how many times did the model predict as negative class. So that will be true negative plus false negative, because this is the total number of records where the model has predicted as negative. Model has predicted as a negative. Of these number of times, of these number of predictions, this many times the model was correct. These many times the model was correct, those many records times. So the numerator will be true negative by true negative plus false negative. This is precision for class 0. This is precision for class 0, and this is precision for class 1. Similarly, I can also see what recall is. Recall is with respect to model, with respect to actual values. That is, of all the actual positives are these, right? So this plus this will give me the actual number of positives, that is true positive plus false negative. That is the denominator, and the numerator would have true positive, that is the correct number of predictions by the model. So this is nothing but of all the actual positives, how many times did the model correctly predict as positive. That is this. Similarly, I can also have recall with respect to a negative class, that is class 0. This would be with respect to class 1. So this would be, recall would be total number of times the model correctly predicted as negative out of all the actual negatives. So actual negatives will be true negative plus false positive. False positive means falsely predicted as positive, which means actually is negative, right? So if you can have a look at here, the total negatives will be this, true negative plus false positive. So this is the recall for class 0, that is a negative class, and this is a recall for class 1, that is the positive class, right? And accuracy is on the entire data, So that's why we have in the denominator all the records. In the numerator we have true positive plus true negative. So these are what we have seen: accuracy, precision, recall. Apart from this, we also have this one, which is F1 score, which is nothing but 2 times precision into recall by precision plus recall, that is harmonic mean of precision and recall. This is used when we consider both precision and recall are an important metric for the given use case. Okay, right? So now let's take each of these use case and try to see which metric would be a relevant metric. So let's take this one, first one, fraud detection. So let's take an example for this. Let's say the number of records I have for normal transaction, and this is for, let's say this is for credit card transactions, right? This is for credit card transactions. That is, out of all the transactions, 98% of the time the transactions are right, they are normal, and approximately 2% of times there would be a fraud transaction. That is, somebody might hack and somebody might lose the money, or there could be some message wrongly delivered, something like that. So there could be a fraudulent transaction which the customer might raise later on. And we want a model to predict this beforehand itself, so that we can stop the transaction, or we can inform about the transaction requirement to the customer, so that the customer will sanction it or not sanction it, right? So that is some business case where we have to identify, given a transaction, if it belongs to fraud or not. Okay, so clearly let's say the class 0, that is not a fraud. 98% of the times it is not a fraud. And class 1, which means positive class, which means it is a fraud, only 2% of the transactions are fraud. Okay, so now let us say I have built a model, right? Could be logistic regression, decision tree, whatever it is. One particular model I have built, and the model always predicts class 0, right? Model always predicts as class 0 for any record, for whatever record it is, whatever transaction it is. All the transactions will be predicted as class 0. Okay, they'll be predicted as class 0. So now let us check what would be the accuracy of this model. So accuracy of this model is total transactions by number of times the model is correct. So let's say there are totally 1000 transactions. All the 1000 transactions will be marked as class 0, right? And we already know this is how the general pattern is. 98% of the time it will not be fraud, that is, it will belong to class 0. So I might have here 980 approximately, okay, approximately, which means accuracy will be 98%. Accuracy will be 98% of this model, right? 98%. If I make all the predictions to be class 0, that is, of all the 1000 transactions, I will predict all the 1000 transactions as not fraud, right? They are not fraud. In that case, I am 98% of the time I'm right? But is this good? Yes, I have a very great accuracy, but actually it's not good, because it's not, I can't even call it as a model, because all the predictions are like made as class 0. So it's not valuable. It's not a valuable model, or I can't even call it as a model, because this is simply mode, isn't it? This is mode. It's simply mode. In the statistics we have mean, median, mode. It's just a mode. It's just a mode model, or just mode, right? It's not any complicated machine learning model which is predicting both class 0 and class 1. I need some predictions of class 1 also, right? Only then I can call that to be a model. Here all the predictions are in class 0, so obviously because of the class imbalance, so here clearly there is a class imbalance. 98% of the time it is not a fraud. So any random guy, if he would call all the transactions or not as not fraud, obviously he will be correct 98% of the time, right? He'll be correct 98% of the time. So if I actually flip a coin, And if I call heads all the times, what is my success probability? It is simply 50 percentage, isn't it? Because probability of heads and probability of tails are both equal, 50 percentage. But if I tell you, hey, probability of heads is actually 0.9 and probability of tails is only 0.1, and now if I predict heads, 5 times, what is my probability of success right now to be able to guess correctly? It's obviously 0.9 approximately here, isn't it? Because there is a probability imbalance. The probability is not equal, right? It's not equal probability over here. Similarly, the probability of being a fraud or a not a fraud is not equal here. And this is called as a class imbalance. The class distribution is not equal. The number of records in class 0, number of records in class 1, not equal. So there is a class imbalance. When there is class imbalance, the probability is different. So I can make any mode model and then wrongly show that the accuracy is this much, right? So what is the lesson from here is that the lesson to be taken is accuracy is not a valid metric to use when there is class imbalance, because that would not give the right interpretation of the performance of the model. So this is the first lesson that you have to take, right? Let me do it like this. See, this is the first lesson. So when to use accuracy? When you don't have any class imbalance, in that case you can go ahead and use accuracy. But accuracy might not be the deal breaker. It might not be the only metric that you have to look. You might have to look at precision, recall, maybe F1 score also. Maybe you have to look at some other metrics, right? So when to do that? That depends upon the use case, like I was saying. So in this use case where there is a class imbalance like this, accuracy is not good. So clearly accuracy is deceiving here, because it is telling me 98% accuracy of the model. If I tell this to any business person or anyone else, if I tell that, hey, my model is 98% accurate in predicting fraud or not, that is like misrepresenting the model, right, to the business person or whoever it is, right? It is not a relevant metric to use. It's deceiving. It's really deceiving. So you do not use accuracy, at least for discussion among data scientists, and stuff like that. So now let us see when the precision and recall would be useful. So the second use case that we were seeing was cancer prediction. Okay, so let's say there is a lot of data about the patients. There is a cancer cell size, there is age, there is diabetes level, there is a lifestyle, there is diet details. Many details are there, geographical details are there. Based on all these details, we have shown to the model, and the model will predict whether the person is having cancer or not having cancer. Okay, so now there are basically two types of error, that is two ways in which the predictions can go wrong. That is, let me write down here, that is false negative, false positive. So what does this mean? What doesn't this mean? This means that false negative means what? Wrongly predicted as not having cancer. This is clearly false negative, right? Negative means not having cancer, but it is false. The prediction is false, which means actually he has cancer, right? Let me get back to that. Now false positive, what does it mean? It means wrongly predicted as having cancer. Wrongly predicted that this person is having cancer. Okay, so what could be the actual information is that he means actually person has cancer, person has cancer, but the model predicted that the person doesn't have cancer. Here it means actually person does not have cancer. Okay, so basically these are the two possible types of errors, of the model. That is, the model can predict that he has cancer, but in real life he may not have cancer, right? Again, the model might predict that he doesn't have cancer, not having cancer, but actually he might have cancer. Okay, so these are the two possible errors. Of these two possible errors, which error do you think is more problematic or more dangerous? What do you think? What do you think is the more dangerous thing over here, which you want to reduce? Right? Just think about it. So, do you think this one or this one? So, if you guess it correctly, obviously, I do not want my model to, predict not having cancer when actually the person has cancer. Right? Because what could happen is, let's say the model is predicting the person doesn't have cancer, and maybe I send the person home, right? I send the person home. After 2 or 3 months, he may, unfortunate things may happen. So I don't want that to happen. As a matter of lives, that should not happen, isn't it? So obviously, what do you think is more critical over here? This one. This one is more critical here. So what about this? What about false positive? What about this? Well, I want my model to have as minimum as this. Obviously, I don't want any kind of error from the model. But among these both, this is more critical, because I may predict a person is having cancer where in fact he might not have, actually doesn't have, but my model is predicting that he has cancer. What could be the big loss? Maybe the hospital might treat him for 2-3 more months or 5 more months, and then maybe some expenses, right? But eventually they will figure out that he doesn't have cancer, right? Model might say he has cancer. It's okay, the treatment can continue. Sooner or later the doctors might figure out that actually he doesn't have cancer, so nothing to worry. Just take the medicines and send him home, something like that. So this is fine. I'm fine with it. Not a very extremely problematic kind of an error, this one. But this is very problematic, because if the model is telling doesn't have cancer, so doctors or hospital might decide to send him home with some minor treatment, and but actually his cancer is not treated and the cancer might aggravate. So that's a big problem. That is not something which the machine learning model should do, as a cost of any life over here. So this false negative, they want this to be high or low. I want more patients who has cancer to be better as not having cancer, or less number of patients. Obviously, the false negative I want to be as less as possible over here. In fact, I want it to be zero exactly, isn't it? That should be the goal, speaking, scientifically. But we all know that overfit and all these, because of all these issues, we can never be able to come up with a model which will perform good on train and test and validation, and also in future data, right? So the aim is to reduce this as much as possible. So in this case, in this use case particularly, that is cancer prediction, false negative is what I want to minimize. False negative is what I want to minimize. Which means, can you tell which metric is important? Is it precision or recall? Which metric is important? Is precision or recall? So it would be recall. Recall is the important metric here, because if you remember the formula for recall, it is nothing but true positive by true positive plus false negative. So yes, true positive by true positive plus false negative. False negative is in the recall. In the precision, I do not have it, right? With speaking with respect to the positive classes, negative class. So don't get confused with respect to this over here. Here you might think I have false negative. No, but we are dealing this with respect to true negative and true negative. So here, with respect to true positives, the model is predicting something as positive, that is having cancer, right? And then not having cancer. So I want to reduce the recall as much as possible, right? So which means, if my false negative is as low as possible, false negative reduces, the denominator will reduce. If this term is reducing, false negative is reducing, which means the denominator is reducing, which means the numerator, which means the entire term is increasing, which means recall is increasing, which means in case of use cases like this, I want to have as big recall as possible, as big recall as possible, which obviously, because we always want as good as big accuracy as possible. But here accuracy doesn't make sense, precision doesn't make sense, because I don't have to worry about false positives, right? In precision we have false positives, but I don't have to worry about the false positives in this kind of a use case. I have to worry about false negatives. As low as possible it should be. So recall is the one which is important in this use case. So let's see the third use case now, which is predict credit reduction. Credit reduction, which means, let's say there is a bank, okay, and banks gives loans to different customers, right? And you want to build a model which will tell that whether I can reduce the credit for this particular customer, yes or no. Credit as in the possible, the amount which can be given for transactions, in the credit card the person is using. In the credit card, let's say person A is this person is having, let's say now, $10,000 of credit which he can use for like 1 month or 6 months or whatever, and this guy is having $5,000 of credit, and so on. And now the bank wants to decide if it can reduce the credit for this person, okay. So it's basically a classification model. For customer 1, yes; for customer 2, no; for customer 3, no; for customer 4, yes. Like this is what the prediction of the model would be. It's a basically binary class model again. So what is the use of this? Because if the credit is reduced, maybe the bank is suffering from some cash crunch or because of recession, so it wants to reduce the credit given to different customers to reduce the risk. And because of this reduction in the credit, maybe some customers might move away from this bank, right? Because let's say the bank was initially giving $15,000 as credit for customer number 3, but suddenly the credit has been reduced to $8,000. Okay, so because of this step taken by the bank, the customer 3 might decide to move to another bank, because this bank is giving him a better credit in the credit card. So there is a chance of customer attrition here based on what the decision would be. So here the model should predict such a way that yes, the bank can actually do the credit reduction, and he will not go move away from the company, move away from the bank, right? Here no, because there is a risk of that person getting out of the bank and going to other bank, which is there is a risk of attrition. So here again the prediction is no, here the prediction is yes, which means yes, I can reduce the credit for this person, and because there is no risk of him going to the other bank, right? There is no risk of attrition. Here do not give him credit, because for this particular customer, do not give him credit reduction, do not give him any credit reduction, keep the same credit. No, because there is a risk of attrition. So that is what the predictions understanding is over here. So here there are again two kinds of error possible, isn't it? Which is true negative and false negative. So negative means what? Negative means what? Here true negative and false negative. True negative means wrongly predicting that the person would actually go out of the company, right? Would iterate, right? Iterate, or there is an iteration, okay? Would move to a different bank. Okay, this is this true. Okay, sorry, this would be false negative, false negative, and this is false positive. Okay, these are the two kinds of errors possible, right? False negative, false positive. So false negative is this, and the false positive would be wrongly predicting that the person would move to another bank. right? Or there could be an iteration from this person, right? So among these two, which do you think is more critical now? What do you think is more critical? So is the company okay with losing customers? Obviously not. The company does not want to, that is the bank obviously does not want to lose its customers, right? So what do you think is more critical here? This is more critical here, false positive, because if the if the model is telling, hey, you can actually reduce the credit for this person, you can reduce it because he will not go away from your bank. He will still continue to stay with your bank, right? That's what the model is saying. But actually, if the credit is reduced for this, the person might go away to a different bank. He might go away to a different bank. Okay, so I don't want this to happen, which means I want to reduce this as much as possible. False positives. False negative, am I okay with it? I mean, I don't want, I'm not okay with any error, but between these two, this is very critical. False negative means what? That I am telling, hey, for customer number 2, do not do the credit reduction, because there is a risk that he might go away. But actually he would not go away, right? Actually he would not go away, but so the credit is not reduced for this person. Still the same credit has been sanctioned for this person, right? It's okay. At least the bank is not losing this customer, right? Bank could have profited by reducing the credit to this person, but at least it's fine because the bank has not lost this customer. But here, in this kind of a situation where the credit is reduced, because of which the customer went to another bank, right? Because my model clearly told that this person will not go to any bank, you can reduce the credit, but the model is wrong. So positive, and it is false, this false prediction is wrong, that's why false positive. So this is critical, which means I want to reduce the false positive as much as possible. I want to reduce the false positive as much as possible. And false positive is present in precision, which is true positive by true positive plus false positive, right? So here, as you see here, this is for precision. False positive. So for this use case, precision is the right metric to use. Precision is the right metric to use. And for this use case, it was recall, and for this use case, it's not accuracy. So accuracy, let me write over here. Accuracy is not right metric here. And you can go ahead with precision or recall or F1 score. F1 score is best over here because it's a combination of both precision and recall, which means I want the precision to be high and recall also to be high. So F1 is good in this use case. In this use case, recall is right metric. And in this use case, precision is the right metric to use to evaluate performance, right, of a model. So this is about the metrics and different kinds of metrics and when to use which kind of a metric. Thank you.